In this video we will be talking about the variables and operators. So variables, we store actually data in the program's memory, and these variables points to that memory. So if you want to use the suppose pi value, you don't need to say 22/7 always. You can actually store that in a value, and you can reuse that value by using that variable name instead of actually using the value, using the actual value. So we can, first one data type is integers, so we can say int a is equals to 5. So let's say 5. I can also declare another variable int b is equals to let's say 7. Now we can also perform the mathematical operations. So a plus b gives the answer 12. We can print that to the console. You can type CW and double tab, and you can see the tab completion. Now we can say a plus b. Now it's going to run this, and we can see the output as 12. Let's also put the breakpoint here. So breakpoint is, we are telling the program, we are telling the debugger to stop at this point. So before the instruction, before this instruction will be executed, and the code stops here. So if I go and debug and click on start debugging, and here I can see the arrow mark pointing to the line 19, and here I can see first this has been executed hello world. That's why I see the output hello world, and we did not see the output 12 because we are about to execute, and I have put the breakpoint. I have stopped the program for a moment so I can analyze the program's memory. So we can go to debug, Windows, and go to memory and choose memory 1. So you can also choose any of this, and now this is the program's memory. We can use ampersand a, and here we can see the value is 4 bytes. So integer takes 4 bytes. These 2 digits constitutes 1 byte. So the 4 bytes from here is 05000000. So this is in the Lithuanian byte order. So we need to reverse these bytes. So that means writing these left to right bytes as a right to left bytes. So the first left byte is 00. So copy this and paste here. And second byte is 00, paste here, 00, paste here, and 05, paste here. So this is the value of my variable a. In the similar way, you can go and say ampersand. So this ampersand means the address, ampersand b, and I get the value 7. So these will be in the beside because on the stack. So you can close this one, and you can also watch the values of the variables here. So that's why it's called watch. You can type a, and here you can see the value in hexadecimal pointing to 5. You can also type b, and here we can see the value 7. So autos are like, whenever you go into the program, whatever the variables the program sees, those will be added. So locals, local to the functions, and the watch one are the custom variables to watch. Now we can step one instruction at a time using this step into. So if I click on step into, only one line of code will be executed. That is our code, which prints 12 to the console. So let's go and click on this and see what happens. And now we can see the arrow mark changed from this position to this position because this is the white space. And now you can see on the console there is a actual 12. If I go and hit something, the program still freezes because the program freezes. See, I am hitting something and it's not exiting because of this breakpoint. it's stepping. So now let's step into this, and now the program actually waits for the user input. Now you can continue this and the program exits. You can also say continue here and the program exits. So this is how you do simple debugging. So this is the integer type. You can also say byte. So byte is values from 0 to 255. That is, byte is let's say int is 4 bytes. Byte is the name says 1 byte, so that means 8 bits. So 8 bits, 2 power 0 to 2 power 8 minus 1 gives you 255. Okay, I think yes, 2 power 8, 256, but the values are from 0 to 255. Yes, 256 values. If I go and say 120, and it should be fine. You can print this value as here. You can run this and you will get the number. If I go and say 320, you will get the error because the 320 is it requires 910 bits, but we have only 8 bits of storage. There are build errors. So value 320 cannot be converted to byte, but 220 can. So byte is 1 byte. Similarly, the character is 1 byte. C is equals to, you can say, capital A. You can print, actually prints the ASCII number. Oh, it was sorry. You can print the integer number as well. So it prints A, and there is string type. String is normally the sequence of characters. String name is equals to say Nikhil, and if I go and run this, name, so I can get the output. And we also have the double and float to store the larger numbers and the fractional numbers. Double D is equals to let's say 90, and float F is equals to 3.14. Did I just pasted reversely? Oh, sorry for this. I just pasted reversely. So you can just print these values. So you can print these values as well. We can also perform the operations, since up to now we have A, B, D, F, right? So we can print A plus D and A plus B and B minus A. B by A, it gives you the remainder. It gives you quotient B by A. B double slash A gives you the remainder. So 7 divided by 5 leaves you the 2 as remainder. It's percentage. It's double slash in Python, I guess. So 2 is the remainder. So you can even multiply as well. 7 5 is 35. You can also compare these values. It gives you the return type Boolean. So bool takes, so these are the comments, double slash, I did not have that. So these are ignored by the compiler. So these are only for the programmer advantage. So like programmer notes. So bool either true or false. So if I go and say bool B greater than A, if I go and print that, I can get the value true. B less than A, it's false because 7 is greater than 5. B not is equals to and b is equals to. Normally in max you can see LHS is equals to RHS by single equal sign, but in programming you need to have the double equal sign. So b is equals to b, of course it's equal, so we get the true. B not is equals to a, so true. So you can use this board to check the comparisons. So we will be using that in the loops. So that's all for this variables and operators.